Welcome to classes on inorganic chemistry, and today's class is coordination compounds, and it is the last part of the previous class, which was 28, and it is in continuation of the class number 28 higher secondary second year, and it is the last class of isomerism, and it is a very interesting topic, and very often in each and every entrance exam the questions are being asked very often. So you minutely follow the last part of the isomerism. That part was stereoisomerism. Stereoisomerism means the isomerism which arises due to the spatial arrangement of atoms or molecules around the central metal. So arrangement in the space. So spatial arrangement occurs optical isomerism and geometrical isomerism. The stereoisomerism is classified broadly into two parts. One is geometrical isomerism, other is optical isomerism. So before starting this one, I have forgotten one simple topic in my last class, and it is very important. This year in NEET 2023, a question was asked from this. Please don't skip the topic. Please, I am going to repeat the same. The missed out topic. Just I have given you the two structure of two complexes. One is homolectic complex. This time in the NEET 2023 question was asked from which one of the following is homoleptic complex. Very simple. Homoleptic complex where the metal ion, central metal ion are surrounded by the same type of ligand. Very simple concept, nothing else, are called homoleptic. And heteroleptic means the central metal ion are surrounded by more than two types of ligands. If the central metal are surrounded by more than two types of ligands are called heteroleptic complex, and the same type of ligands surround the central metal ion that are called homoleptic ligands. This question was asked in NEET 2023. Very simple question, and if you have the knowledge, you can answer it very easily. Now let me come to my topic, geometrical isomerism and optical isomerism. Am I right? So geometrical isomerism generally gives cis and trans type. Cis and trans type. And these types are given by coordination number 4 and coordination number 6. The complex are made up of coordination number 4, coordination 6. You have got already a lot of complexes where coordination numbers are 4, coordination numbers are 6. Am I right? So geometrical isomerisms which show cis and trans isomerism, and that cis and trans isomerism can be shown by the coordination complex where coordination number is 4 and coordination number is 6. So coordination number 4 may be given by tetrahedral complex and Square planar types of complex, because in both the types of complexes the coordination number is 4. One is tetrahedral complex, other is square planar complex. So there is a question of the structure. You must be familiar with the structure of complex. A bit later I am coming, I will in short give you the structures of tetrahedral and square planar and octahedral and pyramidal complex types. I will explain a bit later. And yeah, in short I am telling coordination number 4 are shown by coordination number 4 are shown by tetrahedral complexes square plus both the type of the complex shown coordination number 4 means the central metal is surrounded by the 4 ligand. Here also central metals are surrounded by the 4 ligand, but one is tetrahedral, other is square planar. Why there is difference I will explain a bit later on, but it will not give any type of geometrical isomerism. Orally I am telling you, just you may note it down, because in tetrahedral complex the ligands are arranged symmetrically with respect of each other. The ligands which are arranged around the central metal ion are arranged in a symmetrical fashion with respect to each other. Hence they never show any geometrical isomerism. So geometrical isomerisms shown by coordination number complex having coordination number 4 are square planar complexes. Square planar, here hybridization is sp3. I am showing you just sp2d or dsp2. The hybridization is dsp2. A bit later I am coming. So that type of square planar complex will show you geometrical isomerism. C-sentence type of isomerism. Now it shows only Ma2B2 type. Keep it in your mind, very interesting thing. I will explain. Ma2B2 type. I will show you example a bit later. And coordination number 6 means octahedral complex. It shows cis-tense isomerism M A4B2 M A3B3 M minutely follow. This thing will be a critical one if you do not have the concept or knowledge. Nothing to learn by heart, just you follow. You see, Ma4B2 means a type of the ligand. It is 4 types of ligands are same and 2 types of ligands are different. 4 and 2, 6, the coordination number is 6. Another type, the same type of ligand 3 and same another type of ligand, they are also 3. Ma3, B3, and last type of coordination number 6 which show geometrical isomerism are Ma2B means En. What is En? CH2, CH2, NH2, NH2 means bidentate ligand. So bidentate ligands, any type of bidentate ligands are designated as AA. So here 2 to the 4, 4 to 6, coordination number is 6. Minutely follow, this is a very important type of geometrical isomerism shown by octahedral complex or coordination number 6, because that type of complex may also show optical isomerism. Very critical things. Sometimes you may be given an example. I will show you an example of this type, and they may ask what are the number of the isomerism shown by this one. it will Ma2B2 MAA2B2 will give you 2. One is cis, other is trans. And also in optical isomerism, we will see again it will give you another 2. So it will give 4 type of isomerism, and more advanced way, in critical way, if it is in option given 5, I can say that there is one mesomeric form. Mesoform means optically inactive. Another type is there. So, but maximum of the books it is not mentioned. So it gives 2 geometrical isomerism. So also later we will discuss. It also show 2 type of optical isomerism. So this type of isomerisms are shown by will give you 4 types of isomerism. There are 4 types of isomerism. Such kind of complex will show. Each I will explain the type bit by bit. But before that, again another important thing here, that is a bit not clear in the textbook and very often asked in the entrance exam, solves also in the class exam, minutely follow. Ma3B3 type which show geometrical isomerism, and that type of the complex also show another isomers. There are terms as facial isomerism, and this is minority follow this type. Ma3B3 types will show facial isomerism and meridional isomerism. So for timing, I am keeping this. I am coming step by step. Square planar. Here square planar complex, it shows isomerism. I have not given you an example. The example, best example is so you see it is A2 B2 A2 A2 B2, only one type, A2 B2. So just I am showing you one art of writing C sentence. I have taken an example of octahedral structure. Here it is a central metal and these 6 are the ligands. So you please number the ligand as 1, 2, 3, 4, 5, 6. If the 2 same type of ligand are in 1, 2, 2, 3, 3, 4, 4, 5, don't say 5, 6 because it is equivalent to again 2, 3. Don't again repeat it. So 1, 2, 2, 3, 3, 4, 4, 5. If the same ligands take place, the positions are in this way, then this type of the ligand 1, 2, 2, 3, 3, 4 occupied by the same ligands are termed as cis isomers. And if it is 1 and same ligands are 1 and 4 position, 2 and 5 position, 6 and 3 position, then they are called trans. Just keep it in your mind. Now here in this, if you see that these two are in the same place, same position, then this is called cis. And these two are in opposite, A, B, B are in opposite corner of the structure, then these are called trans. This is called cisplatin, and it is a very important drug for tumor and cancer. Nowadays very often used this as medicine, cisplatin. So this is cis and this is trans, and it is a type of A2 B2 type. First type is over. Cisplatin, mind that, cancer medicine. Now square planar is over. Now let me come to CN, condition number 6, MFO B2. Just very simple to draw. You see, just I have shown you the numbering 1, 2, same type are in the same 1, 2, 1, 2, 3, 4, 5, 6. Am I right? So 1, 2, this is C structure. And that 1, 4, 1, 2, 3, 4, 1, 4. I have shown you earlier. You same ligand, you take 1, 4 position, and others ligands you occupy others as you like. You place, then this is trans. So this is a type of C strands of A4 B2, and here M A3 B3 type. RH rhodium CCl3, chlorine, 3 number of chlorine A3, and B pyridine PH PY3, and you draw the structure, again you will get cis and trans isomerism. So now I have marked you earlier, then this is very important type, because here I will take one example to explain facial and meridional isomers. Facial and meridional isomers, I am taking this example, rubbing off all this. Minutely follow, this is very important. you just show the style or way of writing. This is called facial and this is called meridional isomerism. How? I am showing you. Just you see the same 3 type and same 3 type. A3, B3. This gives you facial and meridional. Very important. How? See, same type are equilateral position, and this same type one is axial position. You may not have idea equilateral axial. I am showing you a bit later. Means two are adjacent. The two same ligands are adjacent. These are equilateral, and one is in axial. Am I right? And on the other hand, other 3 are arranged in this way. 2 are adjacent and other is axial. 2 are adjacent, other is axial. Now I am taking this facial and this is meridional. Why? Just I have changed these two. You see the technique. B, A, B. I have taken B here, A there, B here, A there. See the arrangement, each and everything is same. Now, why it is meridional? Diagonal, because here you see that A, 3A, which 3A, same 3 ligands where 2 side by side, one is axial, or 2 equilateral, one is axial. Now we have seen that same A, which were 2 equilateral, adjacent equilateral, and other is axial. Now all these 3 are equatorial. So this is the difference, nothing else. You will not find in a very explicit manner in the textbook. Just it is given in this way. It is called this and this, and they have drawn a triangular form here. They have shown you it is a triangle. This plane has been used, this and that. So my explanation is like this: that 2 adjacent equilateral, 1 axial. Forget about B, and that 3 once in 2 equilateral, 1 axial. Now all 3 are equilateral. That is called meridional. Now take the example of this. This you see, cobalt is the metal. So you write NH3, A, adjacent and equilateral, and it is axial. And now Na2, remaining part. Now what is the next one? Next part, A. You just interchange these two, Na2, NH3, Na2. So here this is A, like this. Now that A, this is equilateral, axial. All 3 are equilateral. Am I right? Here all A's, 3 A's, 2A are in equilateral adjacent, 1A is axial. Now here 3A, all are in equilateral. This is called meridional. Now I am just explaining one thing to make you a clear picture regarding the structure. What is that picture you see? This is tetrahedral. This is central, maybe carbon, maybe metal. Am I right? Now when you see, there are 4 things, 1, 2, 3, 4. If you assume these 3 are ligand, then in central metal or central carbon ligands are in this way. So total 4. Now what is Square planar. I told you square planar also. You see, central is metal. This is ligand. This is ligand. This is ligand. This is ligand. This is central metal. This is called square planar, and this is called tetrahedral. Please you do closely monitor the way what I tell, no matter what I tell. Tetrahedral means sometimes it is called means three atoms are same plane, 1 2 3, or three ligands are same plane, and fourth is like this. 1 2 3 are in the same plane, 1 2 3 are in the same plane, and the fourth ligand is parallel to this plane. So 1 2 3 are in the same plane, and fourth one is perpendicular to this plane. This is called tetrahedral. But here it is square planar. Its hybridization is sp3 and sp(d)2. The hybridization is d orbital is there. It is this. Why it is called square planar? Because here the four ligand are in the same plane. Here 1 2 3 4, and at the center is metal. So the same plane, four ligand, square planar, four ligands are existing, not like this. Here there is two plane. Am I right? Now another is trigonal bipyramidal, means if there is five ligand. So what's happened? Central metal is attached with five ligand. Three are in the same plane, 1 2 3, same plane, and one is above perpendicular to this plane, other is below. This is called trigonal bipyramidal. Three-dimensional diagram cannot be drawn easily on the board. I am showing you. Three are one same plane, other two are perpendicular to this same plane. Now very important, this is octahedral. This is called octahedral. Six ligands are attached with the central metal. Central metal is this. So here what happens? 1 2 3 4, these four ligand are attached with the metal, are in the same plane. Metal is the center. 1 2 3 4 are the same plane. One ligand is perpendicular to this plane, other ligand is perpendicular to this plane below. Am I right? Now I told you one is equilateral, other is axial. Now I am telling the same plane, which ligands are in the same plane, in the plane position, the ligands are called equilateral. This is equilateral, this is equilateral, these are all equilateral, and perpendicular this plane above and below are called axial. This is called axial. That things you should have a concept, clear concept, otherwise in bonding next part it will be a bit tough. I will explain later on. So there is also bond angle, there is also bond angle. Here is 130 degree, here there is 90 degree, here there is one angle is 120, other is 90. Am I right? Bond angle difference is there. I am not telling about this bond angle, later on I will explain. Just my main motto is to show equilateral and axial. Equilateral means the same plane, the ligands are called equilateral, A, and other is axial, means perpendicular these planes are called axial. Am I right? So you have got some idea regarding this, some structure and some equilateral and equatorial and axial positions of the ligand. So So long I have explained all condition number 4 and condition number 6 all are geometrical isomerism. Now optical isomerism. Optical isomerism. So I am showing you some example. Ma2 B2 type is this type of where platinum, palladium, ammonia and chlorine, and Ma3 whole thing 3 is N plus type, is COEN whole thing 3 positive, MABCDEF iodine, NO2 Cl bromine iodine, and Ma2 Ba2 COEN2 Cl2 Ma2 BC, where these two are different, COEN2 NH3 Cl2. These all different types are the examples of this. So you see this is cis. If it is dextrorotatory, then this is laboratory. So I have arranged simple. I have earlier shown you this is 1, this is 2. The same type is 1 to position. It is cis. Am I right? So I have done its cis D form. PY and NH3 Cl I have occupied these things. So when I have given a mirror, I have taken the image. Participate, there will be the change of the side. The side change means PY has come to this one, ammonia has come to this one, and chlorine has gone to the other side. But top and bottom will remain same in the mirror. And it is the rule of the mirror, you know it. So top and bottom are the same, side change has been occurred in this way. This is the 2 types of the cis and cis type of isomers. Cis D and cis dextrorotatory and cis L. These two are mirror image, non-superimposable mirror image. So this is A, B, C, D, E, F type of isomerism. So if it is cis D, then you place a mirror, just you make the change of the side. So NO2 bring it here, and this here, and chlorine here, and PY here, and write the structure. Bromine and iodine will remain the same. So this is the MABCDF type of optical isomerism. Next type is M A to B2, M A to B2. That is example Cl2. That show two geometrization trends. Now we will show the two optical isomers. So what is En? En ethylene diene. So bidentate ligand. So it is cationic complex. So you see, I have arranged it as like this. You can write in this way also. So here En was in this position, that En has gone to this side and chlorine has come to this side. So the writing of this is also may be written in this way. I have not shown you the way of writing. That is NH2 CH2 CH2 and H2. It is the way of linking. So link with N H2 CH2 CH2 N H2. So in a very short way we can write it En. Am I right? This is the way of writing. So that shows two optical isomerism. That is the another type where we have taken the example as like this. Am I right? So you see, it is not given in your book. I am showing you. This is mesoform. It will not show optical activity, but it will show optical activity 3 En. It is that side is changed already. You have understood how I have done. When I have taken the mirror, we have got this side change in am I not? Now that may also occur. That structure may also occur in this way, exist in this way. So you see, this is in one plane. 1, 2, 3, 4. This is in one plane, square planar plane, like this one plane. So in one plane, one En is one this side, other En is on this side, and another En is along this side. I cannot show you. I cannot show it three-dimensionally. So one here, other here, it can be divided into two equal parts. Hence, it is mesoform. So also in Ma2Cl2 type, there is also a mesoform. In geometrical isomerism, you have seen optical also. In geometrical also, you have seen this is a type. Geometrical and optical also it shows. What we take was MCO En2Cl2. Am I right? We have shown you cis trans, and also we have shown you a bit earlier optical. But out of this two structure, we can draw another structure like this. This is mesoform. Earlier I have shown a bit, earlier I have shown you one En here, other En here, and two chlorine here. When size change, two chlorine here and one En here, other En there. I have shown you a bit earlier. CO this and this. That is one En here, other is in here, and chlorine this. When I give an error, so mirror. So this chlorine 2 and this 2. This is cis and trans. In optical isomerism also it shows optical isomerism. But besides this, it can give you one mesoform. So this is inactive. And besides this C1 En2 3 positive, this gives you two optical isomers. So also it can give a mesoform. It is not given in your book. Mind that in option, if it is given how many isomers there, what two geometrical and two optical, and also one meso is 5, but option is 4. If it is given maximum exam, it is given 4. So you give 4. Don't forget about meso. This is all about the isomerism and isomerisms in optical activity. One is geometrical and other is optical isomerism, and very often lots of questions are often asked in competitive and also in the class exams in your NCERT or board exam. I hope this much in advantageous positions with better knowledge in isomerism in conditional chemistry. In my next class, I will be come with another brilliant part of this one is bonding. Thanks a lot for watching the class.